का लेक्चर और ये तो उसको एडजस्टमेंट नहीं पड़ेगा। वेडनेसडे ऑपरेशन हो जाएगा तो थर्सडे के बाद आप मेरे को कभी भी बोलो, मैं लेकर हाँ मैं सर वो आपको थोड़ी देर में ना मतलब आज नहीं थोड़ी देर में बाद में बताता हूँ कि अभी मेरा एक्चुअली है ना एक इस पे सेक्शन है नोड एमसीयू पे। एक्चुअली क्या है, मैं 7 डेज का कोर्स कंडक्ट कर रहा हूँ और आईओटी विद नोड एमसीयू। तो अभी 5 से 7 उसका सेशन है। ठीक है, मैं आपको कॉल करता हूँ सेशन खत्म करके 7:30 कॉल करता हूँ। हाँ मैडम बोलो। हेलो। हाँ मैडम, मैंने चेक क्या बोला, मेरे को आवाज़ नहीं आ रहा मैडम। अभी आ रहा है, बोलिए ना। चेक नहीं किया मैडम, मैं थोड़ा एक्चुअली क्या है, मम्मी के हॉस्पिटल गया था। अभी 5 मिनट पहले आया हूँ और अभी मेरा लेक्चर है 7 o'clock का, उसका सेटिंग करने का है। तो मैं रात 7:30 के बाद चेक करता हूँ मैं। ठीक है। हाँ हाँ, अभी कुछ नहीं बता सकता हूँ क्योंकि अभी लेक्चर है मेरा, इसके लिए। तो हाँ हाँ हाँ, 7:30 के बाद मैडम, जैसे मैं फ्री होता हूँ मैं आपको कॉल करता हूँ। ठीक है। हाँ हाँ ठीक है, ठीक है, ठीक है। I'm audible. Yes, everybody has joined. Shall we start? Okay, fine. So, any difficulties of yesterday, and that particular sensor is not available. So, most probably on Monday or Tuesday it will be available. And for that, what do you say, ultrasonic sensor, I'll be explaining you as soon as I get the sensor. You know, the situation is going on like that. That is very difficult to make the sensors available. Fine. And on Monday, I'll be showing you one demonstration also of how I've made the social distancing system using this ultrasonic. So let me start. Acha, any difficulties, anybody of the last three sessions? Yes, anyone? See whether difficulty is there or not, at least respond so that at least I'll understand that my voice is reaching to you. Fine. So yesterday what we have seen was the serial communication. So we have seen how the Arduino Node MCU was controlled with serial communication, that is with the help of a PC keyboard. Then we have seen how to transfer these data bytes, or how the PC transfers, or there is a communication between PC and the Node MCU for transferring the data. Then we have seen a simple program for transferring the data from PC to Node MCU, then Node MCU to PC, and then two-way communication between the two. And after that we have seen something about the sensors, and I've demonstrated two sensors yesterday. One sensor was the fire sensor and another was touch sensor. Now today I'll be explaining you something about fire sensor. Just a moment. So I'm sorry, I was supposed to take example of gas sensor. I've already explained you fire sensor yesterday. So first we'll go for the gas sensor. Now I've told you gas sensor is of giving two output. It will give us the analog as well as digital. Fine. Now in this gas sensor, basically the concept of working is thermal conductivity. Inside this gas sensor, there is a filament, and when we pass the air above it or any different type of gases, this thermal conductivity of that particular the resistance of that particular filament changes, and that change in resistance is converted into the change in voltage, and that change in voltage is taken care of what is the terms of gas. Now again here, if you see this potentiometer, fine, this potentiometer is basically used to adjust the sensitivity of the sensor. Fine. So in this way we can adjust, like suppose if I want a very sensitive sensor, then I have to adjust this potentiometer. Fine. And there are two LEDs on this sensor. You can see one here is a power LED. Fine. You can see here there is a power LED over here. Just a moment. So you can see here there is a power LED, and here this is gas sensitive LED. So presence and absence of the gas will be detected with the help of this LED. So this is an MQ series sensor, and this sensor is made by the Figaro company. And there is a series of these sensors. We have a sensor for sensing gas, different types of gases, methane, propane, LPG, and then carbon monoxide, carbon dioxide, oxygen. And also we have to have a sensor to find out air purity. All these are MQ series sensors. Fine, it is MQ series. Fine. So you have MQ2 for gas. We have MQ something for carbon monoxide, and then so on and so forth. MQ135, MQ135 is for air quality. Fine. So these are the different sensors available. Now interfacing here in this diagram, see if you see the diagram, this is connected to VCC ground and this is connected to analog input. Now this analog input will take the data in the analog format. So there is internal 10-bit analog to digital converter and the 10-bit internal converter will take the data, convert it into digital and then display. So very first thing we have to find out the threshold. What is the value of threshold? At what threshold there should be an alerting alarm, and after that only we can go ahead. Now if you see this, now just see the code and tell me whether the sensor is interfaced in analog mode or the digital mode. Fine, I have set the pin as LED as output. I have kept LED as the output, buzzer as output and gas sensor as input. Gas sensor is connected to pin number 8. Then I have set a baud rate of 9600 and then I am reading the gas sensor status, digital read. If it is low it will buzz and if it is high it won't buzz. Fine. So just can you tell me in which mode the gas sensor is interfaced? Analog mode or the digital mode? Yes, in which type of mode this gas sensor is interfaced? Analog or digital? Yes, why it is in digital mode? Can you tell me? How or why you can say or how you can say it is in the digital mode? Correct. Very true, because only high and low are taken and not the exact value. It gives output in high and form. Uh, it is in digital mode because I am testing the value as high or low. I am not testing any intermediate values. Whatever minimum value I'll get is 0, maximum will be 255. It's a variable value I'm getting, then it is analog mode. Fine. Okay, so here we have digital mode. Now what I did here, I am reading the gas sensor and see the command itself says it is digital read gas sensor. If it is low, low means it will buzz the LED and high means it won't buzz the LED. So this is how the code is. Fine. Just give me 2 minutes. I'll turn on the gas sensor code and I'll explain you the things one by one. So here you can see uh, fine, this code I think is visible to everyone. Is this code visible? Gas sensor code? Yes, participants?
Yes, sir, it's visible.
Okay, fine, fine, fine. Now see, this is the same sensor code which I have written. I have explained you that LED I have connected to 3, but I'll make this as D2, and I'm connecting LED and buzzer to the same point, so I'm not marking this, and I'll connect gas sensor to the D3 pin. Fine, gas sensor to D3 pin. So LED is the output. Rest of code is the same, that is pin mode. I'm setting it as output, then buzzer, then gas sensor as the input because it's a sensor. Here there is no point in keeping this line because I'm not using buzzer. I'm connecting LED and buzzer to the same point. Now when the guest, it is reading the digital read, means it will read the status of the gas sensor. Fine, it is reading the status of gas sensor, and if it is a digital value low, it will turn on the LED high. Again I'll remove this part of the buzzer, and it will write gas detected on the serial monitor, and same way when it is high, it will go in the other way round. What I'll do, I'll try to compile the code and transfer it to Arduino. So I hope this code is clear to all.
Yes, sir.
Okay. I think both the screens are visible now. Two screens are visible now. Can you see along with the code this output of IP cam?
Yes, sir.
Okay, fine. So now what you can see is, just a minute. So now what exactly output is available on the screen, both or one? Yes, you can see code and IP cam both, or only IP cam is visible? Yes, please somebody let me know.
Both screen are visible, sir.
Okay, fine. Now if you see this sensor here, fine, on this sensor this very first pin is VCC, then ground, then D0, and then A0. So what I am doing is I am not using this D0 pin. This time I'll be using only A0 pin. So I'll use first pin, second pin, and the last pin. Fine, I'm using first pin, second pin, and the last pin. So first pin is VCC. Fine. So here I'll just connect. This is VCC. Fine, I've connected to VCC. And then black one is ground wire. This is ground. Second one. Fine, see the LED is glowing, means my sensor is properly connected. Now I'll take the analog pin, this red wire is the analog pin, and this I'll connect to A0. This A0 is this first pin here. This is A0. Fine. So my sensor part is over. I've connected sensor part. Now what I'll do, I'll connect LED. In this LED, orange wire is ground. So first I'll connect it to ground. Here this is the ground pin. And I'm connecting this to D2. Fine. This is D0, D1, D2. And also what I can do is gray wire I can connect it to D3. Means even I can take the digital data. So first I am working with digital and then I'll explain you analog part of it. Fine. So let me transfer this code. Okay, so when it is gas status is low, buzzer is high. So let me transfer this code. Okay, there is some issue with the sensor. Just a minute, let me adjust the sensitivity of the sensor. See, already it is showing the detected position. Why? Because this LED is glowing. So what I have to do is I have to adjust this LED now. Just a moment. This sensor has, I think, that pot has gone bad. I'm just take the second another sensor. So this is another gas sensor I am taking. Fine. This sensor was bad. I hope now you can see the green LED which is red LED which is glowing. Fine. So my setup is ready. Okay. See this. Now see, I'm adjusting the sensitivity. Just a minute. Again, all the 4 sensors are not working. I'll just see after some time again what to do. I have one more. Let me check that also. Actually, I have selected gas sensor to demonstrate analog part, but if the gas sensor, see, I've already checked 4 sensors with me. All are not working, all are gone bad actually. What I'll do, instead of gas sensor, I'll take the temperature sensor and demonstrate the same thing. So I'll explain that, and then I'll see again what to do about these gas sensors. Actually, this was something additional which I was supposed to do, but see, this all 4 sensors are not working. So what I'll do, first I'll explain you about the temperature sensor and then I'll demonstrate that. Fine, this fire sensor slide is visible.
No, sir.
Okay. Now,
Yes, sir. Yes.
okay. I'm sorry, this all the gas sensors are not working. So instead of gas sensor, I'm taking another, that is a temperature sensor, LM35. Basically, it was to demonstrate how the analog pin to be used. Yesterday, we have seen how to use digital pin. So I've taken up gas sensor, but it is not working. So I'm taking another sensor, that is temperature sensor, which is LM35. So this is a very simple sensor, LM35. It doesn't require any sort of processing. Fine. It has only 3 pins. That is, one is VCC, other is ground, and the middle terminal is the output terminal. And there is change of voltage, that is 10 millivolts per degree Celsius. The change is 10 millivolts per degree Celsius, means as the temperature increases by 1 degree, the voltage changes 10 millivolts. And secondly, it is very precise one. It can be used from -55 to 150 degrees Celsius, but it gives output as analog, which we have to convert it to digital. So these sensors we are supposed to connect to A0 pin of the node MCU. One is VCC, ground, and A0. So this is how I'll connect. So this will be connected to, even if I connect it to 3 volt, 3.3 volts, it functions. There is no issue. Here there is 3.33 volts. Then I can connect this to pin number A0. Fine. And this ground will be connected to ground. And we'll see the temperature output. Now see this. Very first thing, I have taken reference as 3.3 volts because I am using node MCU. Fine. It is node MCU. Then resolution. Whatever value I am getting, reference, this reference is to be divided by 1023 because I have 10 bit ADC. Means 10 bit means maximum value which I can get is 1023. So I have to convert this 3.3 into the required resolution because I have to multiply that with the temperature to get the exact value. So what I'm doing here is, my reference is 3.3 volts. I'm dividing by 1023, so I'll get the resolution of it. Then you know why, what is the purpose of serial dot begin. Now after that I have defined float temperature. Fine, this f should be small. Analog read A0. Now I'll read the temperature, whatever value I'm getting temperature, I'll multiply by the resolution, and then I'll multiply by 100 to get the exact value. Fine. It is 10 millivolts, so it is, I have to multiply by 100, and then I'll get, after 1 second delay, I'll go on reading the temperature and I'll display on the screen. So this is how I'm using the node, what do you say, LM35. So just it's a 3-wire connection. One is VCC, other is ground, and third is connected to A0. So I'll just connect and give you the demonstration. Fine. This is I've taken the LM35. You can see here. It is 3 terminals. This first terminal is VCC, brown color. First terminal is VCC, that is brown color. Second is the red one, that is the output, and third one is orange one, that is the ground. So I'll connect it here.
Sir, screen is not visible. We are not able to see anything.
Now is it visible?
Yeah, now it came. Yes, sir.
Okay. See here, this I have taken temperature sensor. Fine. This is a temperature sensor. Fine. This first wire is VCC. This is ground, and this middle one is output. So brown color is VCC, orange color is ground, and the middle terminal red one is the output. Now what I'll do, I'll just connect this. See, actually for demonstration, I have taken a gas sensor, but gas sensor is having issue. That's why I'm taking it temperature sensor. This is basically how to use analog read. Now what I'll do, I'll connect here. Now see this. This pin is 3.3 volt and then next is ground. So my brown pin is 3.3 volts. After that, my orange pin is ground pin. And this red one I'll connect it to A0. So my circuit is ready now. Fine, I've connected this. And now what I'll do, I'll transfer this code to Arduino. Fine, the code is uploaded. We'll try to see the output. See the value which I am getting. Fine, now the value is okay. The temperature is, everybody can see this temperature screen?
Yes, sir.
Okay. So see, temperature which I am getting is around 35.48. Now what I'll do, I'll just try to bring a heat source near it, and let's see whether this value is changing or not. Now see, I'm just bringing a heat near it. See, the temperature has changed. Sometimes it may give me some garbage values also in between, because it's just a testing code. See, the temperature has increased and again it will fall down to the room temperature. Can you see this? See, the temperature is now slowly and gradually coming down. Is this clear?
Yes, sir.
Okay.
Sir, can we put bulb near the sensor?
Yes, yes, you can put. You can.
Is it necessary that it should be yellow light or any other
No,
color?
no, no, no. Any heat source, any heat source.
Okay, so it can be tube light also, right?
Yes, yes,
Light
it can be
color.
tube light, it can be anything. See, if you want, I'll just try. I have another source also, but I don't know whether it will be generating that much amount of heat or not. I have another light source. Let's see the output here. So see, slowly and gradually the temperature is becoming constant. See, I have this light source here. Can you see? This is another light source, LED
Yes,
light
sir.
source. Actually, it is the additional flash for my camera, mobile camera. So if I'm
Okay.
bringing here,
Okay.
but it is not generating that much amount of heat. So it will hardly affect.
Yes, yes.
Fine. So it won't affect that much because there is no heat at all.
Yes.
But any sort of heat source, if it is there with you, you can bring it near and it is a precise industry used application sensor. So instead of gas sensor, I'm demonstrating with LM35. I've kept a standby as LM35. So I think this is clear now. So in this way,
Yes.
any analog sensor you can connect and see the output on the serial monitor. And what you can do, you can calibrate it. Like suppose this much. Uh, suppose you have some amount of what do you say? Different sensors. Now suppose if you want 30 degrees, 35 degrees, 40 degrees, 45 degrees, then accordingly you have to do your coding. Suppose if you want that above 35 LED should glow, above 40 buzzer should ring, you can define the code in that way. If you remember in Tinkercad, I have taken 2 to 3 condition for gas sensors. For this much amount of gas, for this much amount of gas, and for this much amount of gas. So in this way it is functioning. Fine. So about the sensors part, I've explained you about the temperature sensor. I've explained about the gas sensor. In the demonstration, I've shown you touch sensor. I've shown you fire sensor. Ultrasonic didn't work, but I'll try if I'm getting the ultrasonic sensor within next 2 to 3 days or till our session ends. I'll try to demonstrate ultrasonic also, or else I'll demonstrate the same ultrasonic code on Tinkercad. Fine. So that much also can be done. So all these things you can try it on Tinkercad also. So now today we'll see how to use this server, this node MCU as a local server. Just a minute. Let me turn on my whiteboard. Fine, tell me, anyone, what do you mean by the word local server? What do you mean by the word local server? Yes, anyone, what do you mean by local server? Host on the local system. Server is also host. Local host machine means current machine. Okay. Okay. Which protocol is basically used in local server? Yes. Okay, is this whiteboard is visible?
Yes, sir.
Okay, fine. So I was talking something about, do we have a local server? No. Okay, fine. Fine, let's see. Now what we'll be doing, first I'll be just explaining you what is the local server and how it works, and then I'll explain you how I can use my node MCU as a local server. So now remember one thing, you have a, just a minute. So you have at your home, let's say a laptop. You may have some cell phones, mobile 1, then you may have mobile 2, then you will have some smart TV. Fine. Now let's say this is operating on data, and these three are connected to one router. Fine, these are connected to router, and with the help of router this is connected to ISP, internet service provider. Fine. So these three are becoming a local network, and they give some information, they can exchange this information through this router. In this router there is one page which is 192.168.1.1. I think this is the address which is for router configuration. Correct? So for a moment of time I can say this router is working like a server because it has this application running on it, along with it is sharing the data. Fine. So this will become a local network. So today what we'll try to do is I'll use the browser. Fine. And I'll make my node MCU as server, and in that I'll keep one web page. This web page will be accessed by this browser, and I'll turn on and off the LED. This will be something different. So this is what I'm supposed to do today. Now about local network you understood. So here what I'm doing is I'm making this web browser, this no MCU as a local server. This can be accessed with this router or the Wi-Fi which is connected to this router. Even I have a mobile, I can load that page. I have a laptop, I can load that page and control the things. Means this application and this application, along with that it will be connecting to my node MCU. Fine. In this there is a web page. That web page will be loaded either in laptop or it will be loaded in mobile, and I can control the LED which is connected to this server. So I'll make use of this node MCU as the web server. Fine. And now which protocol it is using? The protocol which it is using is HTTP. HTTP protocol. Can you tell me what is the full form of this HTTP? Anybody? Full form of HTTP? Hypertext Transfer Protocol. Very good. What is the port number of this HTTP? Anybody? Yes, what is the port number of this HTTP? Yes, port number of this, yeah, 80. Correct. Very good. Port number is 80. Fine. Okay. Now, actually how the system works. There is a client. This client will send a request to some mediator. This is a mediator to the server. To the server. What we call this as request. What this call it as request. And again the server will send a response, and this response will be sent back to us in terms of the data. If data is not found, sometime it gives me 404 code, or it may give is 403, or it may give me sometimes site cannot be reached, or sometime it says wait. All these different codes are available to me. Fine. Now same thing what we do, we give, like suppose if I want to search something on Yahoo, what I do, I open my browser. In that I'll write yahoo.com. First it request goes to domain name server. So I can say this is my DNS. This domain name server will contact to Yahoo's server. What it will do? It will try to contact this Yahoo server. So this from here, it is a request. Then again it will send me the response. I'll show you this request and response protocol today. Fine. So this is how our server will function. Now, what we'll be doing today, first we'll be making our node MCU as Wi-Fi scanner. Means it will detect all the Wi-Fi nearby me and tell me what is Wi-Fi scanner. Now whatever signal I'll get from the Wi-Fi scanner, okay, I'll get the name of the Wi-Fi available nearby me and I'll display all those names. Second, what I'll do, I'll try to make a web page using HTML which will help me in turning on and off the LED. Fine. So till this point I think everything is clear. Which protocol I am using? I am using HTTP protocol. I am using HTTP protocol. So till this point, if anybody has any difficulty, just ask, let me know, or else we'll proceed further. Okay, good. So I think there is no difficulty. Everybody is getting what I've explained you. Fine. Now I'll just share the Arduino screen. Now in this, what I have to do is, today I have to use a library file. So I have how to install library file. We'll see even that. How to install so I can install it with the help of IDE also, and I can install it manually. How to install manually? First step is download the like the library file which you need from the internet. Fine. Let's say if I need for Wi-Fi, I'll search for the Wi-Fi file and I'll download that. If I need for LCD, I'll find it for that. So you will get something called as zip file. Now what you can do, you can unzip in your machine, and that folder X, now it will convert it into a folder X. Manually what you have to do, you have to copy this folder. In the Arduino folder, you will be having one Arduino folder, Arduino working folder. Now where is this Arduino working folder is? It is in C drive, documents. Under this documents there is Arduino folder. Under this Arduino folder there is libraries folder. Under that library folder you have to copy this x.zip. So this x.zip, whatever the file you have unzipped, basically this unzipped you have to copy in this particular folder. Fine. So you have to go in C colon documents Arduino libraries. I'll show you the library. So very first thing is you have to download the library. Already I have downloaded, already I have installed, but then too I'll show you all the steps. Second is I have to do through IDE. So I'll show you that. So what you do in that is you have to go to sketch. From sketch you have a menu called as include library, and from that include library you will go to add zip. Fine. So what will be your steps to install through IDE? You will go to sketch, under sketch there is include library. Once you go to include library, you say add zip file, add zip. So what will happen? It will help you in adding that particular file. So once you click add zip, what it will do? It will ask you the path from where exactly you want to add the file. Fine. So these are the two steps you can add library to the Arduino. Because I need libraries. So what was the first step? Manual. In manual step, what you will do? You download the zip file, unzip it, and copy that unzipped folder to documents slash Arduino slash library folder. And second step was I have to go to sketch menu. From sketch menu I have to go to include library. Under that you have manage library, under sketch there is manage library, and then you will go to add zip file, add zip library. Here you have to give path of the zip file where your zip file is stored. Fine, I'll give you both the demonstrations. So is this both the methods clear how to update your IDE? Is that clear? Yes. Anybody, any issue in that? Fine, what I'll do, I'll try to share the, first I'll show you the folder where exactly this library file is. Just a minute. Fine, is this browser available visible to you all? Yes. Is this browser visible to all?
Yes, sir.
Okay. Now see, if I go to documents folder here, in documents folder, you can see Arduino folder. In this Arduino folder, you can see these libraries. Fine. So all these libraries are installed in my system. Libraries are related to ESP8266, MQTT, then sensors, then libraries are related to the blink sensor, then DHT sensor. Fine. All these libraries are loaded here. So you can see the zip folder, zip files also here at the bottom. Fine, you will get libraries in the zip format and you have to upload that. So this is the one way what you can do. You can unzip and copy these folders here. Fine. So you will see all these libraries here. See, there is an library which will be using today, that is ESP8266 Wi-Fi. It is already being copied here. If you need all these libraries, just let me know. I'll copy the zip file in the drive and I'll share the link with you on Monday. If you need, just let me know. All these libraries are available with me. No need to search anywhere. Fine. So I'll be using this ESP8266, and especially BSc ID student, you also have a Telegram application with Raspberry Pi. For this, Telegram library is needed. Telegram bot master library is needed. Fine. So these are the zip files. So this was the first method how to install the library. What you have to do, you have to go to documents, you have to go to Arduino, you have to go to libraries. In that folder is to be copied. Fine. The next is I'll share with you the Arduino. Fine. So I'll share the Arduino screen. Fine. So this is the next way to install library. I have to go to Sketch. I'll say include library. In that you will have add zip library. Fine. In that, if you click, it will ask you the path where you have stored the zip files. So what you have to do, wherever you have stored the zip files, you have to give the path of that. Let's say I have some zip files. See, here I have a libraries folder. So I can click this and add this libraries. So once I say okay, I won't click okay now. Once I click OK, what will happen is it will add the libraries. So is that clear? Any issue, anyone? Was it screen visible what I have shown you? Yes?
Most of the people.
It is freeze now. The screen was freezed, correct?
Yes, sir.
Okay. I'll just show you once again. Now the screen is, see, can you see this highlighting portion?
Yes, sir.
Okay, I'm sorry, the screen was freezed. Again, I'll show you. You have to go to Sketch. include library. Here it is include library, and you will say add zip file. Once you go to this, wherever is your zip file located, you just click that. Fine, you have to just click, and wherever is your zip file, that is my library zips are here, I'll say okay, and it will get added. Fine. So understood how to install the zip files. Till this point, everything clear? Any issue, anyone? Yes, any issue, anyone? Please just somebody give the feedback. Is understood or not? Fine. Now what we will do, I'll explain you code how I have to find out what all Wi-Fi's are connected to, what do you say, my node MCU, nearby my node MCU, what all Wi-Fi's are available. So for that, I've made a code called as Wi-Fi scanner. It's a very simple code. Fine, we'll see step by step. So I think that code is just a minute, Wi-Fi scan. Okay. Can you see this code now on the screen? Yes. Have you seen this code on the screen? Can you see that?
Yes, sir.
Okay. Now see, in this, I am including very first ESP8266 Wi-Fi. What I'm doing is, I'm including here ESP8266 Wi-Fi. Now, once you include this, means you have added all the files or all the headers or all the functions or all the classes which are needed for this application. I've made available to this application. Now see, while writing Wi-Fi, both the eyes are small. Only thing you have to keep in mind is both the eyes are small. Then what I've done in setup, I have first initialized my serial communication so that my system can communicate with the PC so that I can see what is the status in the node MCU presently. Then I have written Wi-Fi dot mode. Now this Wi-Fi is the variable, okay. So I have made it as Wi-Fi dot mode, that is a class, and mode is a function. In that I have passed a constant. This constant Wi-Fi, see, it is completely, it's a constant. Wi-Fi stationary means keep my node MCU in the stationary mode, means I don't want initially any network connected to it. My node MCU should be as, like if there is any previous network connection, just I have to remove that. That's why I've written the next statement as Wi-Fi dot disconnect. So what this will do, this will see to that at the starting of my code, none of the networks are connected to node MCU, not a single network. Fine. And then I'll say print setup completed, means my setup sees to the things that There is no Wi-Fi connected, not a single Wi-Fi connected to node MCU initially. Now in a loop, what I did, print scanning network. Now it will scan the network. This is just a message, nothing to do with actual scanning. Actual scanning is in the next line. Here I have written integer n equals to Wi-Fi dot scan networks. Wi-Fi dot scan networks. Now it will start scanning, like same way your cell phone start scanning the networks nearby. Fine. So what it will do, it will try to scan all the possible networks which are available. If actual networks are available, it will give that much number of count in this n. Fine, I'll get that much number of count. Fine. So n will tell, suppose if one network is there, n will be 1. If 2 or 3 networks are found, it will give me 2 or 3. Fine. After that, I'll just write scanning completed. It will come to this line. When scanning is completed, it will just give a message. And if n is equals to 0, n equal to 0 means there is no network found. There is no network. So it will print a message, no network found. But what about the if there is a networks? So if there are networks available, then what it will do? It will give that much number of count how much network is available. So here I am writing a loop for integer I equal to 0, I less than n, I plus plus, and I'll print Wi-Fi dot SSID of I. Fine. And then bracket will start, and then I'll write Wi-Fi dot RSSI and the bracket closed. Now just can you tell me what is this SSID and RSII? And remember one thing, if RSSI is 0, it is, no, I'll not tell. Just let first you guys guess what this 2 means. SSID is a name given to Wi-Fi in characters to identify it. Very fine. What is RSSI? What is RSSI? What is RSSI? Yes. Fine, I'll tell you. SSID is service set identifier. SSID is service set identifier, nothing but your the name of your Wi-Fi network. And second is strength indicator. So it is received signal strength indicator. RSSI means it is just a moment, okay, received, that is R, signal strength indicator, received signal strength indicator. 0 means the signal has nice strength and it will give you negative values. More the signal negative, weak is the signal. Weak is the signal. So what it will do? It will print. Now see how the output will be. Wi-Fi SSD. So it will print the name. Let's say my Wi-Fi SSD is XYZ. Fine. Wi-Fi is XYZ. Then there will be opening bracket. Why? Because I have given here the opening bracket. Then in that it is writing SSD. So let's say I'm getting minus 27. Bracket close. Why bracket close? Because here I'm closing the bracket. And after that what will happen? It will just print a next blank line for the next blank line for the sorry one single space, and after every 5 seconds the process is repeated. The scanning process repeats after every 5 seconds. So I think all this are clear to you. That is what is Wi-Fi.ssid, then why this opening bracket, and then why this RSSI, and why this closing bracket. And once this process is over, once it has displayed all the Wi-Fi available, and then it will tell wait for 5 seconds, since I have given a delay of 5000 milliseconds, and after that the process will be repeated. So students, anything till, or the participants, any problem till now? Have you understood this code? Have you understood this code, or anybody want again the explanation of this code? RSSI. Okay. See, I'll tell you in some other way. You have seen your mobile, and when you scan a network, it will give you multiple names. But automatically, what mobile does, it will connect to the signal which is having the maximum strength. So RSSI means it is received signal strength indicator. So in a Wi-Fi, now when I'll start searching, I'll get 3-4 different Wi-Fi's. Once I get 3-4 different Wi-Fi's, what will happen? Now to which I should get connected, there is a problem. Fine. Now to which I should get connected? To find out that, I have to write a code that which is having the maximum strength, connect to that. Here anyways I'm not connecting it to anyone, I'm just doing scanning. When I'm just doing scanning. Now if value to RSSI 0 means it is the best strength, it won't get positive value, maximum you'll get 0. Fine. And always you will get a negative value. Now suppose you get a strength as -10, -20, -30, -40. Suppose you're getting 4 signals, -10, -20, -30, -40. What exactly that means? It says that you have 4 signals. Out of that, so strength is 10 is good, strength is 20 is little weaker than 10, strength is 30 means it is like weaker than 20, and strength is 40 means it is again more weaker than 30. That is third signal. This is how the things works. So is it clear? RSSI is cleared. RSSI is clear now. Okay, anyone any issue with RSSI or SSID or this particular code? Just a moment, please. Just a moment, excuse me. हाँ सर बोलो. हाँ सर बोलो. हाँ सर मैं एक 15-20 मिनट रुकोगे, सेशन चालू है, मैं सेशन के बीच में हूँ. 15-20 मिनट में खत्म हो जाएगा. हाँ हाँ हाँ. ओके ओके. Fine. So I think everybody is clear with this code. Anyone any difficulty? Just let me know or I'll proceed. Okay, fine. So just give me a moment. I'll turn on the serial monitor. Okay. So I've executed, I've uploaded the code, and I'll just show you the output. Now you can see here, I'll first clear this and I'll reset the Arduino. Just a moment, I'll just put it down. I'll turn on the अरे मैं लेक्चर चालू है, 7 बजे खत्म भाई, बातें बात 7 o'clock. So see, is the screen visible now? All the screens? Yes, all the screens are visible. Yes, anybody? Okay.
Yes, sir.
Okay, fine, fine. Now what I'll do, from here, I'll just press a reset. Prior to that, I'll clear the screen and press a reset. So that thing will start. Now see, it is telling me scanning the network. Scanning completed. If you see the code. And then it is detecting Jai Gurudev -84. It is getting Gurudev EXT -80. Tell me which is the good strength. First one with 84 or second with 82. See, the signal strength is changing. Now what I'll do, I'll turn for a moment my mobile hotspot also. Okay, even if my hotspot remains on, nobody bothers to connect it. You will get the answer when you'll see the name of my hotspot. So I've turned on my mobile hotspot. Let's see it is detecting the third signal or not. It is scanning for the network. See, it has detected the third one also. See, the name is virus detected. Since the name is virus detected, nobody bothers to connect. So whose signal is more better? Which is the better signal? Gurudev EXT. Negative value is lower. Very good. So I hope everybody understood how I am scanning the network. See, you can use your node MCU as a network scanner. You can find out what all networks are there nearby you. So understood how I'm, see, this is detecting the network only. Right now it is detecting the networks. So is this clear? How I can connect, how I can detect this node MCU, help in detecting the Wi-Fi networks near me. Now what I'll do, I'll write a program to connect to my home network or my Wi-Fi network. Fine. So I'll be explaining you that code. Now before going to the actual code, I'll just first demonstrate you what I'm supposed to do. Fine. And then we'll go with the code. Just give me a moment. Just a moment, I am downloading the code in the Node MCU, and first I'll show you the output, what exactly I'm expecting. See, I've changed the code, and now I'm getting one IP address from my server. I'll just share the screen so you will understand. I'm not explaining you anything. मेरा browser किधर गया? Okay, fine. This is my browser here. Okay, I'll open one more instance of the browser. Fine, I have one more instance of the browser. Okay, I want the IP scanner. I want general server com8. Okay, fine. Now I hope you can see three screens. One is the IP cam, another is a simple browser, and here see I am passing you 192.168.1.133. This is the Wi-Fi, my local IP address. Can you see these three screens? Yes. Can you see these three screens?
Yes, sir.
So whatever the code which I've run now, which is executed, that will is returning me this IP address of my machine. See this. Fine. Now once I write here 192.168.1.133 and just press enter. See what has happened here. A new request received. Can you see this? A new request received. Again, if I refresh the page, what is happening? A request is received, and see there is a LED control with local server. I'll get this type of code here. LED control with local server. See, I have not written code here. This is not from my hard disk. This code is coming from 192.168.1.133. Fine, you can see this is the code which is given from the scanning. Now, if I just write here some data, see, after this, I'm writing slash and I'm writing Manoj and press enter. Now, see, it is going request. This request is stating the data as Manoj. See, you can see here somewhere you can see that data. Whether let's say it is available or not. Say it is not available here anywhere. Fine. But if I write just a moment, if I write here slash on, see this on has came here. Can you see this? Yes, because my code is written in such a way. If I write off here, see the data is going off. You get a data as off. Why? What I'm doing is instead of pressing a button, I'm just clicking here. Now see here, I'll just press, I've just loaded my Wi-Fi and I'll say LED on. See here, it is going as on. Fine. If I say LED off, see here the data is going as off and I'm receiving here. Now I'll just remove this and now you can see the things here. Fine. Just a moment. So when I click the button of the browser, what I'll get is I'll get LED turn on and off. And where this browser is stored, this this web page I have stored in Node MCU. See, now I'll click on. This LED is turned on. See here, I've used the LED which is there built in on the system. You can see here this blue LED. If I say LED off, the LED is off. If I say LED is on, LED is on. If I say off, it is off. So this is practically which will do. Now this particular web page is stored inside the Node MCU because I'm making my Node MCU as the server. Fine, I'm making my Node MCU as the server. I'm sorry. Okay, so if I say off, if I say on, the LED is on. If I say off, the LED is off. I'm using the built-in LED which is there in the Node MCU. On, off. Fine. Now let's see what is the code for this. I'll explain you the code for this. Okay, my Arduino code. Okay, I got my Arduino code. Okay, now can you see this code on the screen? Yes. Can you see this code on the screen? Okay, fine. Now see what I have done in this code. I have taken first the Wi-Fi header ESP8266.h. Then in setup I have written 9600 as usual. I have written Wi-Fi mode same. I have written Wi-Fi dot disconnect. and my setup complete. So before starting scanning the network, it will first verify that my all the networks are existing networks are disconnected from the system. Means it will is working fresh for the network. Now in the loop what I've written, scanning the network. After scanning the network, same code, it is the code is same till this part. Okay, I've taken a Wi-Fi scan code. I'm sorry, I have to take a local server code. Okay, this is the local server code. Whose this is on? Okay, so just a moment, I have to take a local server code. Fine. Now see, in this case, very first thing I've taken one character pointer SSID, and this is my Wi-Fi network's name, Jai Gurudev. Now whatever your Wi-Fi network name, you will select that. Very first thing, you will select the respective Wi-Fi network name. Then you will keep the password. Now see, this is case sensitive. You have to strictly see that the password here is same what you have actually kept for your Wi-Fi network. Then I have started Wi-Fi server. Wi-Fi server, the variable is server. Can you tell me what is this 80? Can anybody tell anyway? What is this 80? Yes, HTTP port, because by default request goes to HTTP port number 80. Fine. So this is two things which are three things I have added. Here I have used the new class Wi-Fi server. Now serial.begin 9600. Here I have used built-in LED, a variable. Fine. Why built-in LED? Because I'm using the on built-in LED. Also I have used pin D2 as output. Then I've kept Wi-Fi as a stationary, disconnect, setup complete. I've shown you. Now here, serial print connecting to Wi-Fi. Connecting to Wi-Fi means now it will start connecting to the new Wi-Fi network. Now Wi-Fi dot begin. What I need to give to the Wi-Fi network, SSID and the password. So it will try to connect to that SSID Wi-Fi network. So there is a variable called as WL connected. If it is getting a value true, means you are connected to the network. If you are getting value false, means you are not connected to the network. So I'm writing not WL connected, means if you are not connected to the network, it will just print dot and wait for 500 milliseconds. So what will happen? Unless and until you get connected to the network, it will just go on printing dot 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 dot. Fine. And once you are getting connected to the Wi-Fi network, it will break this loop, while loop, and it will come here and it will say Wi-Fi connected, and it will display the Wi-Fi IP address, local IP address. I have shown you it was 192.168.1.133. I have got that to my node MCU. So it will give me serial.print Wi-Fi.local IP, and then I'm writing server.begin. So till this point, my server has started. Where is that server? That server is in my node MCU. What my node MCU is doing? It is trying to get connected to my local Wi-Fi. So now this system will work only when your Wi-Fi, your laptop, your cell phone, your node MCU is connected to the same network, because it is a local network. I'm making it as a local server. Fine. Any problem till this point? Every command is clear, or you want any command to be explained? So till this point, uh, I'm not using any specific web server here. No, I'm making a simple code which is acting as a server, and my device is node MCU. Inside that code is residing. I'm neither using Apache, I'm not using not Tomcat or not Jinx. None of the web servers. Those are global servers. I'm using local. I'm making my node MCU as a server. Try to understand that. If I want to control my home applications, then I can use my node MCU as a server and all the devices connected to that particular server. Fine, is that clear, Mateen? Yes, till this point, any issue in the code? Please let me know. So here the server will be started. Now what? Who is the server now? Server is my node MCU. Yes, in that Wi-Fi server is available in this ESP8266 Wi-Fi.h. ESP8266 Wi-Fi.h. Wi-Fi server is a class. Now, remember one thing, my node MCU is acting as a server and my browser will act as a client. So what I'm writing here, Wi-Fi client equal to server dot available. So it will check whether the server is available or not. Fine, if server is available, client will get value. If it is not client, means suppose it got value as 1, means not client is not there. So, oh sorry, it got a value as 0. So not 0 means it will be 1, it will return. Means if server is not available, code won't execute. It won't go further, it is telling return. So yahin se wo program return ho jayega. Now, if it is getting client available, it is printing new request received. I have shown you the new request received. The moment some activity is happening on the browser, it is doing some sort of request. Fine. Now, string request equal to client dot read string until /r. Till you plus /r, it will read all the strings. What it will do? It will print all the strings. So it will print whatever the request you are getting, it will print that request. Now in that request, there will be value. We have to search a character /on. Fine, because when I press the button, it will give me the value as /on. When I press the off button, it will give me value as /off. So what I'm doing, I'm finding the index of request dot index of /0. Now /0 means what? If you are getting a positive value, means that variable this value is available. If you are getting -1, means /on is not available. If I am getting -0, /on is not available. Keep that in mind. Fine. So if on is available, what I'm doing here is I'm turning on built-in LED. Along with that, what I'll do, I'll write digital write and I'll turn on the LED which is connected to D2. Fine, but for D2 I have to write high, because built-in LED works on the reverse logic. Built-in LED works on the reverse logic. Fine. Now, so and on the serial monitor it will print LED is on. When I press off button, exactly the reverse thing will happen. What will happen? It will turn off the built-in LED, as well as I am writing a code here. I'll make this as low, means that LED will be off. Till this point, the LED turn and off has done. But where is my browser yet? Suppose if I'm not writing the code for browser, then what? Fine, just a moment. What I'll do, I'll just put this code into comment. I'm not writing this code at all. I'll explain you what this code is afterwards. Fine. I've marked this and now I'm putting this inside the node MCU. I'm uploading this code. Till this point the code is clear. What is happening? When the request comes, there should be on, and when the request is not there, there should be off. Is that clear? See, the code is big, that's why it is taking time to write in the Arduino. Array, again I put the oh, 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 oh. So now can you see this? So it is connecting to Wi-Fi. See, it has got an IP address 192.168.1.133. Is it visible to everyone? And now even if I click a button, it won't affect because I have not written the code for that. Fine. Now see here, I am passing from here on. Fine, I'm just passing from here the value array, where it has gone. Okay, on. Let's see what happens on the screen. See here you got, see, get slash on HTTP 1.1. Okay, get slash HTTP on. So if I say it is off, if I pass on the value off, see here it will say get slash off HTTP 1.1. Fine. So this is what is the request which is coming from the browser. Even if I pass any random value, let's say it is printing or not. See here it is slash get ABC HTTP. Once I press enter, it will send 3-4 requests at the same time. That's why you are getting ABC, 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 ABC and all. Fine, but since I've blocked the code, it is not giving any effect on the node MCU. Fine. Now what I'll do, again I'll unblock that particular code. I'll unblock that code. Now what I'll do, okay, local server here. Now what I did here, I'm writing client.print. Client.print means what? It will print HTML, title, LED control, title. Okay, that is my title of the web page. Just a moment. Fine. So what I can say is this is my title of the web page, LED control, and then on the page it is printing LED control with a local server, and then I have taken two buttons, LED on and LED off. So these two buttons, what they do, they basically pass on the value. See, it is href slash on, href slash off. The moment I'll get the value on, my LEDs will be turning on, and the moment I say value off, the LED will get turned off. So that is what is the change in the code. So this particular part is creating the web page. I got a IP address 192.168.1.133. That is my local server's IP address. So the moment I request a local server, what it gives me, it loads this web page. The moment I say google.com, the request go to google.com and it displays the web page of the Google. Same way here, I've created a local web server. I've kept my local web page and I'm controlling LED with that local web page. Fine. So I'll try this. I'll burn this, download the code in the Node MCU. Till that code is downloaded. Yes. Have you understood this? What I'm trying to do? Have you understood what I'm trying to do? Yes. Anybody, any issues? Please let me know. Okay, now just see here. See, I have put here 192.133. I'll clear the output here, and you can see. First, I'll reset the node MCU. I've done the reset. Now see, it is connecting to Wi-Fi. My Wi-Fi scanning program will work. It is connected to Wi-Fi and it returned me the IP address 192.168.133. The moment I put this IP address here, I'll get 192.168, this web page. Now from where this web page is coming? This web page was stored in the node MCU. Now I'll say LED on and LED off. See, this LED is off now. Fine. and now I'll say LED on. See, this is also glowing because I've connected D2 also now. Buzzer is also connected to the same line. Now I'll say LED off. It is off. Now same way you can create multiple devices, multiple buttons, and you can control multiple LEDs. Fine. And one LED can control one relay. So you can control multiple devices. See, the moment I click on, see here I'll get on HTTP 1.1. I got the value on here. So since this value on, LED, I get a message LED is on. If I say it is off, I'll get a message LED is off. So I hope this understood everyone. Yes, now is that clear everything? Understood how I can make my node MCU as a local server? Yes, everyone understood? Geeta madam, are you there?
Yes, sir.
So have you understood this concept? What I am doing is, participants and madam, professors, teachers, those who have connected, what we did today is, we have first scanned the network, and then I have made one small application that is loaded inside my node MCU, and from HTTP request I'm loading that particular page, and then I'm controlling that particular application, which helps in loading the turning on and off the LED. So on my local browser you can see there is an LED on button and there is LED off button. The moment I click this LED on, request goes to node MCU and it takes action depending upon that request. So anybody, any difficulty, just let me know. So I hope the things are clear to you. Anyone, any issues, just please let me know. Yes, you can make node MCU as a global server also. Yes, you can make. Fine. Even you can run this now at the local server. I can control the same application from my cell phone also. You can make it global. Global means you want to control your node MCU from the different place, from your cell phone, from the different network. Yes, it can be done. It can be done. Yes, anything else? Anything you want to ask? So I hope something new apart from the regular LED turning on and off sensors. We have seen something new today. We have made this as a local server. On Monday's session, we'll be taking up with DHT and we'll be connecting that DHT to the ThinkSpeak so that my sensor data will go to, what do you say, the cloud, and I'll display in terms of graph. Fine. And if time permits, we'll see how to send the tweet message. If time permits, that is not part of it, but then I'll try my best. And on Monday, what we'll do, we'll take one temperature sensor, one temperature humidity sensor, and I'll try to find out the gas sensor if it is connected. the temperature, humidity and gas, all the three parameters, I'll put it on the ThinkSpeak. That is the local connecting to the cloud. And on the next, that is Tuesday, we'll be controlling the same thing, DHT and all, with the Blink app. We'll see the output on the Blink app. Control with the Blink app. So it will be the app control, and then if time permits, we'll go for MQTT. Yes. Anything else? Anybody want to ask, or I'll sign up for the day? Madam, how the session was of today?
Sir, it was nice.
I've-
Something new in a different way through network we can connect and get to know.
Okay, okay,
And
fine.
devices can be controlled.
Okay. Yes, participants.
No, tomorrow session won't be there, students. Tomorrow Sunday.
No, no, not tomorrow. When I say tomorrow, it is next working day.
Hmm. Anything else, students, you want to ask? Sir, one question in the chat box.
Yes.
So, sir, Node MCU is capable for running a web server?
Smaller ones, not the actual web servers. Actual web server is something different with a lot of securities. This is for the smaller application. For the local application, it is best. You cannot go out for the global application like big web servers, no, because it doesn't have that much capacity. Yes. Anything else?
Any other question?
Today we have seen one of the example of web server only. We have created a very small web server with some few lines, few codes. Fine. Actual web servers you cannot create on the Node MCU because it doesn't have that much amount of memory also. It has hardly some 32 KB of memory. So on 32 KB memory, nothing happens basically. Just imagine if I'd ask you to take a cell phone with 32 KB of RAM. You know, it will be like a flying chapel. Yes. Anything else or any difficulty in the last 4 days session? Fine, ma'am. I hope I'll sign off now.
Yes.
And we'll continue on Monday.
Yes.
Okay, fine. नंबर पिन कोड लिखी दे, ठीक है, काले पल्ला तक बता दिया कोण कणे जाणू काय जाणू, ठीक है, बट खाली अपन फोन करी तो फोन ने बट जानी तो अपन कहणू पड़ी मतलब भूल होगा वणी कहणू के मतलब अभी एज ज्यादा है तो वही आ व्यक्ति, ठीक है, ने ओके क्यों करावनो છે કે બીજું जस्ट फॉर सिक्योरिटी एक क्योंकि मार्क्स पार्टी केस था खबरो मारी बात મને मन का क्यों खबरो मार्क्स पार्टी केस था, ठीक है, મને बिना मर्यादा मोरत पार्टी पूरू नॉर्मल है, ठीक है, तो जस्ट एक सेफ्टी कि हमारी दादी एज वाली है जो हमारी दादी का कराना बीजा करना नहीं कराना ने वाडर खाली नहीं आ व्यक्ति हमारे डर लेना वाला रिस्क नहीं लेना पण एक गलती थी पण थोड़ा ऑपरेशन करावनु है या थोड़ा कोई बीजू है कोई केजो मत अगर कहियो ऑपरेशन करावनु का कहते कि ऑपरेशन માટે गवर्नमेंट में क्यों नहीं करातो पहले तो वो पूछ लिया, ठीक है, ने का करी रिपोर्ट में लगा पॉजिटिव घना घना करे बीजा ऑपरेशन वास्ते सिक्योरिटी वास्ते